Well, hello guys. Today we are going to be reviewing some new videos that Genetic Beast has uploaded, and well, he has mentioned me in one of those videos. So as I am the one who put forward in the first place the arguments against him, I will respond to what he has to say because that's basically my responsibility. If you are going to say something, then you have to be willing to back it up. So I will do it, and I will mention him in my title of the video so that he knows that I have replied to him. Not like he has done literally in the last like 5 videos we have reviewed, in which he mentioned me indirectly and he was responding to my arguments in the said videos. So let's dive right into the videos. First of all, we are going to just take one fragment of this video because most of it isn't even a counter-argument to what I was saying, and doesn't have literally anything to do with what I put forward as arguments in the last videos. And also, not only that, not only the arguments that he puts forward right here don't have anything to do with whether what I'm saying is true or not. Basically, he's talking about things that are unrelated to the topic in discussion. But also, most of the like 2 times that he has tried to criticize myofibrillar hypertrophy independence of muscle damage, he's repeating arguments that I have already debunked. So I'm not going to take the time to go through all of this section right here, but you can perfectly go to that video, see if there is something that serves as a counter-argument to what I say, and tell me, and I will be happy to address it. So now let's dive right into it, shall we?
As the nuclear division, nucleus, see?
Sorry, I didn't put the video at the right part because this is taken out of context, basically.
This section here, they talk about hypertrophy is defined as the increase in the ratio of cytoplasm to nucleus, see?
He probably doesn't even know what that is trying to refer to. That is basically trying to refer to the next thing. If we take a myofiber, in this case, and we put multiple nuclei inside of it, right here, this is a myofiber, not a sarcoplasm. So if the size of this fiber increases in this way right here, with the amount of nuclei inside of it remaining the same, then we can perfectly conclude the nuclei are usually more near the walls of the myofiber, but since this is kind of a 3D representation of the thing, just let's consider that these nuclei are near the walls of the myofiber. If we see an increase in area, in the volume of the myofiber, while the amount of myonuclei have remained the same, then we can perfectly assume that hypertrophy has occurred. This is hypertrophy, right? Sorry. This is hypertrophy. Now, obviously, before this has happened, what the myofibrillar domain size ceiling hypothesis is trying to say is that some myonuclei were added inside of this fiber to support further growth, because with the amount of myonuclei that this myofiber previously had, let's say for example that the myofiber was like, the same size, was like this previously, and let's say that it had like, instead of 6 nuclei, it had 4 nuclei. These nuclei are not enough to cover all of the myofiber. The domain that each of these nuclei have in regards to the organelles that they can control to then produce to synthesize protein and add it to the myofiber to make it bigger, let's say that. What they basically do is add some building blocks to expand the myofiber in size, and basically the myofiber gets bigger. The problem with this is that what the myonuclear domain size ceiling hypothesis is basically saying is that each of these myonuclei have a limited domain. So they want to be able to control the organelles that are right here, and right here, and therefore they want to be able to produce more proteins to expand the myofiber more. So you need to add more nuclei, like let's say 2 nuclei, to then be able to use these organelles to produce more protein to expand the myofiber. So what basically is being said right here is that after this incorporation of 2 myonuclei has occurred, the fiber is now able to expand and get bigger. But in the first place, you don't need these myonuclei, and we are going to see that later with his second video that this is true. Okay, let's see if I am actually recording. Yeah.
Ratio to cytoplasm.
So what basically is representing this ratio of cytoplasm to nucleus is the increase of the size of the myofiber without the increase in nuclei, which basically means that the size of the myofiber itself has expanded, even though the amount of nuclei have remained the same. So you have more cytoplasm than that nuclei inside of your myofiber. That's basically hypertrophy.
Plasm to nucleus, whereas...
Which he probably doesn't even know what it is, because he's even reading this as he really doesn't care about it, even though he's going to later try to use it to support his arguments.
Hyperplasia is defined as the nuclear division. What's a division? Dividing. Cells are dividing. Oh, that's...
Yes, but what cells are being divided? The cells that are dividing are the myonuclei inside of the myofibers, which in normal models cannot divide and create extra myofibers. Okay, what is basically happened with hyperplasia is that the nuclei inside of the myofiber are dividing and basically creating more nuclei out of the nuclei that we already have inside of the fiber. So what is basically happening is this right here. We have our fiber again, and we have our nuclei. Basically, what happens with hyperplasia is that each of these nuclei go through nuclear division, which basically makes the cell split in two, and you end up with 2 fibers that have each of them 6 nuclei. Okay, this is hyperplasia. That's basically what is saying right there.
It's hyperplasia. See, nuclear division and an increase in the number of cells. And if there's an increase in the number of cells, that's called hyperplasia.
Yes, which was never actually proven in human beings, but he's going to try to address that in a very bad way, I could say.
That's why they're telling you where hyperplasia is defined as the nuclear division. See, where Blaha...
Yes, but repeating words won't make you understand what is actually trying to be said with that. You don't understand what the concept of hyperplasia is, because you are repeating nuclear division without actually explaining to your viewers what it is. So by repeating something, you are not going to end up disproving those that are going against the notion that hyperplasia can occur in humans, because he's going to use this argument to try to prove that hyperplasia occurs in humans, and that's nonsense.
Jason Blaha and all the rest of these people on the internet are telling you that hyperplasia doesn't exist. Well,
now that's clearly a strawman. We are not saying that hyperplasia does not exist, because it was proven in rats and in other mammals, but it wasn't proven in human beings at any point in time. And you cannot say that human beings are the same as rats, because as we have previously shown in one of my videos, in which we captured the study about androgen receptors, which I believe was the video about androgen receptors and mechanical tension right here, or maybe other other video. We can even look for it in this file. Let's look for AR or for rats directly, or mice. We have, I don't remember exactly where the study was, but I remember that I do have a study, or well, a citation from the study about androgen receptors, which talks about the discrepancies with other studies, right here. Yeah. On the other hand, various muscle groups and types react differently to exercise interventions. Smith et al. Stated that rat SC content did not increase following 1 week of running on a treadmill or 30 minutes per day. In contrast, Paris et al. Report a significant increase in satellite cell number and activation on mice 2 and 4 days after they run on treadmill. So, what basically happened is that, let's see if I can actually find the full citation about the discrepancies with the mice. But, yeah. Our data are in sharp contrast with those of Uphoff et al. Indeed, their study based on analysis of MARKO, which means that the gene of the ARN messenger that is in which the information about androgen receptors is codified was taken out of the mice. Knockout means KO. And basically there were unexpected results from previous studies of mice in which AR is ablated in the germline. The term ablated, if we search for it, basically means to get rid of and to separate, to remove basically. And that's something that we will use in the next video, just so that you can understand. So you cannot make the case that human beings are the same as rats or mice, because we have a lot of studies that show discrepancies between mice when it comes to androgen receptors, and we have studies that confirm in humans the notion that androgen receptors do regulate myofibril hypertrophy, and they do so by IGF-1 regulation, okay? So...
Well, it does exist, and what is it? Hyperplasia is defined as the nuclear division.
Why is he going to repeat it like 30 times? He's not going to do anything by repeating the same thing over and over again. He's not making his point. He's just doing what is called argumentum ad nauseam, which is basically repeating the same thing even though it has been already addressed or it was already understood. So this doesn't make any sense.
What is that? Myonuclear domain size limit had reached the ceiling limit during hypertrophic process, beyond where the extra nuclei donated by satellite cell to support further muscle growth. Get it, man?
That's the myonuclear domain size ceiling hypothesis, not a theory, because it was not. It was disproven by later studies. So what he's basically saying is that, what I basically explained before, that you need more myonuclei to be able to control more of the organelles that are in charge of producing protein, which are ribosomes, and basically, since you need more of them to produce more protein, and your nuclei can only control a certain part of the cell, of the myofiber, which is a single cell. We're talking about a single cell with multiple nuclei. Then we have to increase the amount of myonuclei that we have to control more organelles. That's basically what he's trying to refer to in his case, right? But you are not actually proving the fact that you need to add more myonuclei to be able to produce more proteins, because as we are going to see in the study about the myonuclear domain size ceiling hypothesis being dead, we are going to see that myonuclei behave in a very special way that makes them able to even produce more protein, even synthesize more protein after reaching their domain size, and basically expanding the myofiber.
And look, I'll even read this to you, okay? Here, I'll bring it up for you. Just in case you don't understand this. Maybe people, they don't get it, dude.
Let's put the recording at 2 times speed.
Okay, it's called myonuclear domain size. See, this is myonuclear, right? Okay, so let's go back here. What do they say? Oh shit, I lost that, damn it.
He just searched for a study to to show that the myonuclear domain size is called such a thing in the literature. What does it have to do with the argument in the first place?
I hate when that happens. Okay, so this is from that section again, modes of hypertrophy. So what do they say here? They say that whereas hyperplasia is defined as the nuclear division and an increase in the number of cells, right? That's what it is, right? Okay.
Why is he repeating all the time what hyperplasia is? He's like not very. He's not behaving in a very conventional way. He's like just to not say the word crazy, right?
Myonuclear domain size limit. MND size has a ceiling limit during hypertrophic process beyond which extra myonuclei are donated by satellite cell to support further muscle growth.
That's the hypothesis. That's not by necessity true, since there are studies challenging this notion. So
how does the satellite cell donated through muscle damage? That's how it is activated.
No, that's not how satellite cells are donated. We have been through numerous pieces of evidence that prove that satellite cells do not need to be donated by the action of damage, which is producing some mitogens that later activates satellite cells and makes them go to the places where some kind of injury has been produced. You don't require damage to activate satellite cells. We have been through it in numerous videos, so I am in a lot of videos, so I'm not going to repeat my arguments over and over again, because he hasn't actually addressed the arguments in the first place. But you can perfectly watch my previous videos that already have timestamps included in them, and you can perfectly read the docs that talks about proliferation of satellite cells in myofibers that haven't been damaged, or you can also find some articles that talk about mechanisms that are independent of damage, which means that they are activated by something different than damage, and also regulate some things like mTOR pathways, and therefore end up upregulating satellite cell activation and fusion, which is internally regulated, which basically proves that you don't need anything external like damage to actually make them fuse. As a matter of fact, you don't need differentiation for the satellite cells to fuse. Differentiation only occurs when you're going to form myoblasts to replace a myofiber that was severely compromised, that had necrosis of the tissues, and that has been basically gone through a very almost total destruction of its structure. And that's not what we want for hypertrophy. We want, well, I don't want really micro injuries, because they are not needed to grow and they are leaching resources from the actual process of growing. But what he wants is basically what Genetic Beast wants are micro injuries, and he's not getting them in this case because he hasn't gone through the process of getting rid of the repeated bout effect, which lasts for 8 to 12 weeks. You can perfectly see that in this article, this document, or in my previous videos. And also, he basically, based upon what he's saying, that you need differentiation of satellite cells for them to make you grow, he's making his satellite cells grow. So he isn't really achieving what he wants, even though he says that he knows what he's doing in the gym. But well, let's keep watching this video. Let's try to not find logic where it clearly is absent. So
through muscle damage, and that's how it does it. Okay, dude? That's how it does it. I'm sorry, shit, man. This thing went off again. Fuck, it does this all the time. I have to go back there again. Sorry about that. That really sucks. You know, you're trying to make a point, and this is so, like, interrupting. I don't know why it does that. The problem is, I have so many videos here, I can't get to the information because they're sequenced.
That's why you should actually make, like I did, a docs in which you take the most important parts of the information that you want to talk about and you present that in a single document. You should do that. We are not the ones responsible for going through your more than 1,000 publications in your community section and go debunking each of it. That doesn't make sense. And also, next week we're going to be debunking some things about goatees. We're going to I'm going to be doing this debunking in a documentary form. Let's see if you actually like that way of making videos, because it's basically going to be a presentation with some slideshows and basically a PowerPoint, in which we are first of all going to present what Coatis says, what his claims are about exercise, and then we're going to categorically debunk them by basically incorporating them all in a list and attacking each of the elements of that list by the studies that I have already gathered, like 4 months ago, well, but I didn't have time to make videos about goatees because Genetic Beast constantly tries to make videos responding me without actually addressing what I'm saying. I am going to propose you one thing before we keep watching this video. If you're watching this video, Genetic Beast, if you don't actually care about what I'm going to say, which are basically counterpoints to what you're saying, then stop claiming that your way of training is the one that everyone should follow, and criticizing literally every fitness content creator in the internet, because what you're preaching is being put into doubt and you're unable to defend it, okay? And if you are actually unable to defend it, then you are not the one to be saying that others are wrong, because you yourself are wrong. So what I'm going to propose you is that you stop stalking every single content creator in the internet unless you're actually going to respond to someone debunking what you say in the same way you try to do that with other fitness content creators, because you're being incredibly hypercritical. That's basically my proposal. Just stop making videos criticizing people and actually make something constructive out of your content, because this content is terrible.
Alright, so let me go back here, different modes again. So now you understand it's about nuclear division. What is nuclear division? Myonuclei. Hyperplasia is defined as nuclear division. Nuclear division, myonuclei. And
not really. Nuclear division is not myonuclei. Nuclear division is the division of myonuclei. It's not the same to say that, okay, a car is a vehicle, right? A car moving is not a vehicle. A car moving is a vehicle moving. It doesn't make sense to say that a car moving is a vehicle, because a vehicle is a car. We don't need the car to be moving to actually define it as a vehicle. In the same way in which a myonuclei is not a nuclear being divided. That doesn't make any sense. Please try to use the correct words for what you're trying to communicate to other people.
an increase in the number of cells. Okay. In contrast, hypertrophy of skeletal muscle starts to involve the increase in the number of nuclei as well as the increase in cytoplasmic volume. Hypertrophy of skeletal muscle therefore incorporates part of the definition for what? Hyperplasia. So it does exist. Okay, man? It doesn't.
Yes, but it incorporates only part of the definition for hyperplasia, an increase in the number of nuclei. So it isn't literally hyperplasia, right? What we are talking about here is not the same as hyperplasia. And just because it's defining it does not mean that it exists in human beings. I can perfectly define, let's invent a word, for example. Let's take the word marktoplasm, for example. Marktoplasm. What does it mean? Well, I can make a definition for that word, but even if I define that word, it won't make it actually a thing that occurs in reality, because I can perfectly talk about something that was never really observed. In the same case, hyperplasia has never occurred in human beings. So it has occurred in other mammals, but not in human beings. So by defining the word, you are not actually proving that it has occurred in human beings.
It just exists in fucking birds that they did a test on with a locket. Oh.
Yes, it just occurs in other animals, if that's what you're trying to refer to. Unless you bring some evidence to prove that it occurs in human beings, you cannot actually talk about it occurring in human beings. So
okay, an increase in the number of nuclei. As further complications, the additional nuclei may come from internal nuclear division or fused satellite cells and their donated nuclei. That's evidence of DNA synthesis and hallmark of what? Hyperplasia. Okay, dude. So are we clear with that, man? I hope so. Here's another one.
Yes, that's basically laying out what hyperplasia is. That's not proving that it occurs in human beings.
Diffusion and beyond satellite cell contributions to loading induced skeletal muscle adaptations. So you can read this for yourself. Diffusion.
Loading induced muscle skeletal adaptations. You clearly understand that loading something does not imply breaking it, right? If I take, let's say, a machine in the gym that uses a system of pulleys, I don't know how to say it in English, but a system of ropes to actually try to lift something. Let's say that we're talking about this machine right here. When you're pulling stuff down using this machine, you're basically loading this rope or this string right here with weight, and in this case he's loading the rope with literally every single blade in here. So you are loading the cable in this case, but the cable is not actually being broken down by you loading it. You understand that, right? The cable is not experiencing. If the cable were to experience actually breakage, then it wouldn't be a good cable for your machine. So this thing right here, a cable, is experiencing mechanical loading and is not being broken. Okay, so mechanical loading does not imply damage occurring. That's false. So if mechanical loading can be something that you basically take it as independent of damage, as a separate thing, as different from damage, then what the title of the article itself is already talking about goes against most of your notions, because if you can have hypertrophy by just mechanically loading your muscles, and as we have already seen, that cannot be justified as sarcoplasmic hypertrophy, because it cannot actually justify any significant amount of growth, then basically that goes against your entire argument. I don't understand how you went through it completely unnoticed, but...
With that, man, I hope so. Here's another one. Fusion and beyond satellite cell contributions to loading induced skeletal muscle adaptations. So you can read this for yourself.
And this is worse, because it's talking about satellite cells, so he cannot use the excuse of sarcoplasmic muscles. That doesn't even work.
Fusion of satellite cells driven by the cell and autonomous and or extrinsic factors contributes new nuclei to muscle fibers associated with what? Load-in-induced hypertrophy and may support focal membrane damage. What does this mean, load-in? May
support focal membrane damage. And the membrane of the muscles, of the sarcolemms, is not this, well, of the cells in this case, so we are talking about the myofibers. Damaging the membrane is not by necessity micro injuries, because you can compromise the structure of the membrane without actually causing breakage inside of the myofibers. What basically saying is that the fusion of satellite cells driven by cell autonomous or extrinsic factors contributes new myonuclei to muscle fibers, basically what we were talking about before, associates with load-induced hypertrophy, and may support focal membrane damage repair and long-term molecular transcription output. So what is basically saying is that satellite cells and increasing the satellite cells, in the myonuclei that you have inside of the myofiber may help you repair that myofiber in case that some damage has been done to the structure of it. But it's not saying that satellite cells only repair damage and will only be activated in presence of damage. So let's at least hope that he's not going to make that wrong conclusion.
Induced hypertrophy. They're talking about protein synthesis needs to exceed that breakdown. The contract.
Load-induced hypertrophy is not the same as protein synthesis having to be greater than the amount of protein that you're breaking down. That's literally nothing to one thing with the other. Load-induced hypertrophy is just talking about increasing the amount of load that each myofiber is going through, and after that experience some hypertrophy. You do need protein to experience hypertrophy, but the word itself, the phrase load-induced hypertrophy, is not strictly referring to the synthesis of more protein than what you're breaking down. So I don't know what he's even trying to explain with this.
Proteins, the cytoplasm of that cell can only get so big, it's overseen by the MND size limit. So what is it?
Not really. The cytoplasm of the cell can get bigger, as we are going to see later with the other study and the other video.
You need to do, you need to reach that, you need to force that domain and then damage muscles. So focus more on food, being an animal.
You want to force that domain and then damage muscles? I thought that it was literally the opposite way, that you had to get more myonuclei to actually make the cytoplasm expand, and that based upon what you're saying. and that these satellite cells can only be incorporated as myonuclei once damage has been received. So you're saying literally the opposite in this case. Satellite cells, as we have already proven, don't need damage to be activated and to fuse to myofibers. But
metabolic growth state, push that domain, and then it'll donate its nuclei to support further muscle growth. It won't support it on a bagel and cheeseburger McDonald's dinner, okay?
yeah, because satellite cells and the production of proteins does not involve at all ATP nor any form of energy. Okay, you don't need energy to actively produce or synthesize proteins. You don't need it at all. So, ATP is basically extracted from glucose. So no, you don't eat anything related to sugar. You don't need it, basically. Well, it's true that you can produce sugar from proteins and from fats, as we have seen in the other video, in the previous video. Not the one about the sulfur, but the previous video to that one. And basically, after we have talked about it, we basically arrived to a conclusion that you should also have quite upregulated sugar or at least glucose levels inside of your blood, even though you're a carnivore. So you do need sugar in some way.
Whatever, lunch, bro, it ain't gonna work.
And how are you going to extract energy in an efficient way from just fat and muscle alone, from just eating some meat and some fat? The process of creating more carbohydrates and the process of basically creating glucose and all of that involves the active expenditure of energy. So you need to expend some energy to actually turn all of that into carbohydrates, and it will happen no matter what you do. So it is better that you put some energy that is not that does not belong to that cycle, just so that you can recover the amount of energy that you have lost because of said cycle, which is what you can do by incorporating carbohydrates in your diet. That's why I basically recommend them. And well, you need meat obviously also, but you actually need carbohydrates. You cannot just omit them and say that they are the same as sugar, because not every carbohydrate is sugar by definition. As a matter of fact, you have sugar is only, you can only talk about sugar when you're talking about cyclic carbohydrates. If you have something like, what was it? I don't remember its name, but you can have carbohydrates which are not a closed chain, and that wouldn't be a sugar. I don't remember the exact name, but let's keep watching this video.
If you ain't in an anabolic growth state and you're not pushing that domain beyond that hypertrophic limit, then it will not donate its nuclei regardless if you damage muscle fibers. That's why I'm very careful in my exercise regime. I never go to the gym to lift weights if I can't be in an anabolic growth state. There's just no point for me to lift there. I'm gonna waste my time to do what? You
do not need to be in a caloric surplus to actually grow muscle. You understand that? You understand that the energy that you actually need for your muscles to increase in size can still be provided by the fat that you have, which is why body recomposition works, right? And also, you can just maintain the amount of protein that you are consuming, and just down-regulating the amount of carbohydrates and fats that you are consuming to do a caloric deficit, and you will still build muscle. That doesn't make any sense.
Not gonna get anything. So yeah, that's what they're trying to explain to you. Satellite cell supports skeletal muscle fiber adaptations to loading in numerous ways. In numerous ways, bro. Get it? The fusion of satellite cells driven by cell autonomous and/or extrinsic factors contributes new myonuclei to muscle fibers associated with what? Load-induced hypertrophy. What does that mean?
Which is not damage.
What does that mean exactly? See what I mean? What does that mean to you? Still has to reach the domain limit. And they support focal...
Not really. We are going to see that in the next video, man.
Membrane damage repair and long-term myonuclear transcription. Output. Recent studies have also revealed that...
He doesn't even know what transcription is in the first place, but that's right.
Satellite cells communicate within their niche to mediate muscle remodeling, response, and resistance exercise.
In response to the resistance exercise, which is not the same as in response to damage, because those are two different things. You can do resistance exercise with almost little to no damage, as you can perfectly see in the first study that I cite right here, in which IGF was upregulated in both cases, despite one of those cases having less damage than the other, considerably less damage than the other, and still the same growth was experienced. And you can perfectly see that we're talking about myofillar growth because IGF-1 strictly regulates satellite cells activation and fusion. So, well, it doesn't, as I have already said, fusion is internally regulated by satellite cells, but what we are saying basically when we talk about fusion is that some factors, in order for satellite cells to proliferate enough and for you to have enough satellite cells, they stop the process of fusion temporarily, and the process of migration of the satellite cells, just so they can proliferate more, and basically so that once they arrive at the place, you have more satellite cells for them to fuse to the actual myofibers. And in this case, we are talking about IGF-1, which is upregulated even in the absence of damage, or even if the amount of damage goes to almost zero in this case. So basically, that already proves that you don't need damage to grow, but
regulating the activity of numerous cell types throughout various mechanisms such as, I don't know what the fuck they're talking about here, secretory signaling and cell-cell contact, whatever, muscular adaptations, resistance.
Secretory signaling, it's basically referring to hormones, I suppose, but well.
And resistance, whatever, activities, and so forth and so on. They're going to go on forever there. They're going to read it all. Cell types are various. Okay, some here actually. Signaling cell contact, muscular adaptation, resistance to initial. Sustained for periods of time, the absence of satellite cell partition. What the fuck is this?
Participation. How is he that illiterate that he cannot read one single word right? And it's not a very difficult word. We're talking about participation. That's not a very difficult word to actually understand.
Maybe just say cut off here. Participation is ultimately required to achieve full adaptive potential. It is. Yeah, whatever. Okay, be it growth.
He doesn't even understand what the word itself means because he failed to actually say it right, and he now says, yes, you're right.
Function or perspective coordination, but it doesn't grow without any material called food. Okay, if you don't eat food, it's never gonna grow. Okay.
Yeah, if you don't eat anything and you don't have enough resources inside of your organism, you want to create matter out of thin air. That's right.
So there you go. While significant progress has been in understanding the roles of satellite cells in adult skeletal muscle over a few years, decades, many conclusions have been extrapolated from regeneration studies. Okay, whatever. I don't know if I posted any more. Did I post any more stuff here? Many conclusions have been extrapolated from regeneration studies. Highlights. Okay, yeah. Satellite cell behavior and contributions to adaptations. It usually does give it to adaptations.
He doesn't even want to read the things that he's citing out loud. So if you don't even have the will to actually study what you're going to talk about, then why are you actually bossing around and criticizing other people when you cannot clearly defend your own theory or the things that you are basically posting, that you're basically saying on your channel? Why do you criticize others for not being able to or basically for being wrong when you are actively doing saying falsehoods inside of your channel and not even backing them up, or even in the case that you try to back them up, you just read something completely unrelated that you haven't even studied, and like you doing so in such a way that it seems like you didn't even want to do it in the first place? That's terrible.
So you know what? Food is an adaptation too. There's an adaptation of muscle growth through protein synthesis, disease breakdown. That's an adaptation. You can call eating.
That's not an adaptation. That's an event occurring. So I don't understand how that could be an adaptation, but okay.
An adaptation. If you don't eat, then one adaptation cannot override the other adaptation. In other words, without one adaptation, the other one won't work. If you don't eat.
Without one adaptation, the other one won't work. Eating is not an adaptation by itself. And also, why the false dichotomy in the first place?
It's not going to work. So whatever you do there, forget it. The adaptation outside of regeneration in adult muscle, as well as the roles of satellite cell beyond fusion and myonuclear accretion.
Yes, but you don't need, satellite cells are not only involved in cells regeneration, so that's also wrong.
Just gaining broader recognition. Yes, it's not anything new, man. It's old stuff already. This is all fucking old news, bro. But anyways, I hope that helped, man. I can't go into further detail. I post a lot of stuff in here. It's way down at the bottom now. It's all lost already. So you got to scroll all the way down. I'm not going to scroll all the way down.
Yes, and you should actually take all of that information and put it into a single doc. That's what you should do.
The bottom. But you get the gist of what I'm trying to explain to you here. You know what this is.
No, you don't even understand what you're talking about. So.
In the next one, friends, I gotta go. Tell me what you think about that. Like, subscribe, support the channel. I'm gonna go. I hope that helped. I don't know. Maybe that helped. That didn't help. I have done sequences on some of these reports previously. I talked about them. There's some videos way backed up and down at the bottom down there somewhere if you want to check it out. And it does. There's such a thing as sarcoplasmic hypertrophy. Okay, and one can exceed.
No, there's no such thing as what you're presenting it as. Sarcoplasmic hypertrophy itself does exist, but it cannot justify any significant growth, and you're trying to use it to justify significant growth. So in the way that you conceive sarcoplasmic hypertrophy, it does not exist.
The other one can exceed One can exceed the other. You understand me?
Yes, but what is actually being exceeded in the study that you are citing is the ratio of one thing to another. You're not actually citing they are not actually examining the ratio of the volume occupied by something in relation to the other. Because if we would actually see the volume that one thing occupies in comparison to the other, we would see that sarcoplasmic hypertrophy occupies almost, sarcoplasmic hypertrophy, no, the sarcoplasm itself occupies a portion incredibly small of the myofiber itself. We have already seen that in the previous video, in which I showed an image of the myofibers inside of the cells, a sagittal cut of this myofiber, and you can basically see that the fluid in between each of the myofibers inside of the sarcolemma is the sarcoplasm, and that sarcoplasm is already incredibly small. So a significant increase in sarcoplasm, or which would be like, for example, duplicating the size that it occupies, will still make your myofiber not that big. So because the size that you are increasing is already small, so multiplying by 2 won't get you a really big number. If I multiply 0.2 by 2, I'm just going to get 0.4, which is not a big number. So
In other words, myofibular growth.
if this represents the size that you're gaining, then you cannot justify any significant amount of size increase with sarcoplasmic hypertrophy.
Can exceed sarcoplasmic, and sarcoplasmic can exceed myofibular growth. But sarcoplasmic hypertrophy training, sarcoplasma training.
No, the amount of sarcoplasmic proteins that you have is what was measured in that study, I believe. Not glycogen, not fluid, not anything like that. The portions that one thing occupies in relation to the other, the volume that one thing occupies in relation to the other, was not actively measured and put into a radius. So
Is not regulated by follistatin, myostatin, or the satellite cell, or the myonuclear domain size limit, which is satellite cell. Okay, it's not regulated by that.
yes, but well, it's actively being regulated by some of those things, because in order to actually expand your myofibers, you have to at least expand in some way in the sarcoplasm to not end up causing myofibril packing, which has a limit. Actually has a limit, because you cannot keep packing more size inside of the same restricted volume forever. At some point you're going to completely cover the volume, and you will have to increase the amount of size of the sarcoplasm itself to keep growing. So since you need it for growing the myofibers, I would say that it's actively regulated by that.
Okay, it's not controlled by that. It's controlled by how much glycogen you're loading in the muscles.
Not controlled by glycogen. We have already been through the study about the 6 weeks. No significant increase in glycogen, even though sarcoplasmic protein content increased, and no significant increase in fluid content. And that's literally in the video on sarcoplasmic hypertrophy of House of Hypertrophy that you cited inside of your community section, which proves that you cite things that you don't actually watch.
There has to be a window there for glycogen synthesis, not protein synthesis, but glycogen synthesis. And since the majority of people,
You don't synthesize glycogen inside of your muscles. You understand that, right? That's completely different from synthesizing proteins.
you people going in the gym, getting the pump, chasing the pump, and getting this pump, and doing this weird pump stuff, pump work, whatever, that's basically sarcoplasmic hypertrophy.
That's not sarcoplasmic hypertrophy, because sarcoplasmic hypertrophy is not related to the fluid content inside of your muscles. We have already been through this in previous videos. I'm not going to repeat myself.
This man, and you're drawing every gram of glycogen, 3 grams of water, dropping skin and muscle into the muscle.
Yes, but the maximum amount of glycogen that each kilogram of muscle can actually hold is incredibly small. We have been through that in the video about sarcoplasmic hypertrophy. So, even though you actually draw that amount of glycogen of water into your muscles by each gram of glycogen, the amount of glycogen that you can hold inside of your muscles is incredibly small.
Also creating phony, fake muscle.
Not that much.
It's artificial muscle growth, okay?
Not fake muscles, because there's no such thing as fake muscles. You haven't even defined it, and you haven't even explained why that would be fake in comparison to your protocol of increasing the amount of myofibers that you have, even though you cannot actually use all of them because you need to increase your motor units count to actually do so, to actually recreate more satellite cells. So sorry, satellite cells, to actually recreate more myofibers. You're doing the exact same thing, and you're not calling yourself some fake bodybuilder. So
I'll see you in the next one, man. Like I said, don't skip out that like, subscribe, support the channel. You get the gist of it, man.
let's see the other video.
It's T-Man, and I'm back with another, you could say, I guess, an educational video. So, I've mentioned before on my channel, I posted it, and, there's this guy always trying to debunk me, he's going to debunk me, he's always writing in the comment section. Well,
yes, I am not trying to debunk you because I have something against you. I would actually make the same claim against what you're actively doing towards other fitness influencers. You are criticizing every single fitness influencer apart from you in each of these videos. So you are the one which is obsessed with other people and with criticizing them and with debunking them. So you are the one who is wrong.
see you in the next one, ciao. If you're debunking what exactly? The information from NCBI PubMed?
No, I am not debunking the information from NCBI because NCBI actually debunks what you say. I don't know if you remember, guys, but in a previous video we talked about a certain rule that can be applied for Genetic Beast in every situation in which he brings up some evidence. That evidence is going to contradict his immediate claim or contradict some of the previous claims that he has made. So no, I am not debunking NCBI. I'm actually debunking how you are using the articles and why they are being used mistakenly, I would say.
Is that what you're debunking? Because you're not debunking me, because I just keep bringing up the information. So you see...
Yes, I am debunking you, and each time you try to bring up some information that does not actually address my actual arguments against what you are saying, what your thesis is about muscle growth, I don't have the need to go and debunk you, because in the first place, bringing more information does not debunk the arguments that I upholded. If I decide to argument against something in particular, and in response to that you start talking about birds and how birds fly and how birds eat, you are not actually debunking what I'm saying, but just taking more information from a certain source and repeating it over and over again. You are not addressing my claims. That's what I'm saying. By getting more information inside of your channel, you're not actually addressing the arguments that the other person is upholding, so that's wrong. Just because you're posting more information in your community section does not mean that you're actually responding to the things that I am saying, so that's wrong.
Debunking me. You're not debunking me, you're debunking NCBI, and you're not doing a very good job at it.
I am not debunking NCBI, and the one who is not doing a very good job is the person that we have seen in the previous videos, not actually research the things that he's going to talk about before doing so, and when he actually goes to read the things inside of the article, he doesn't even know what basic words related to that areas of investigation mean, and also reads them like he is a zombie, that he's someone who wants to die without any show of intention to actually understand or teach that data that he's bringing.
Whatever. Anyways, now we're going to talk about myonuclear domain, because I remember a while ago we talked about this. They said, well, there's another part here that says, is myonuclear domain sealing hypothesis dead? Like, he goes, well, there's a way to get over it. There is always a way to go over it. I talked about it before. But yeah, okay. So...
Yes, and your way to get over it is not what is being explored in that article right there. We're exploring the fact that you can actually keep increasing the size of your myofibers without increasing your sarcoplasm. And also, when you increase the size of your sarcoplasm, you're not increasing the size of your myofibers. So you're not actually getting through the myonuclear domain size ceiling with sarcoplasmic hypertrophy. That's also wrong.
Well, yeah, is myonuclear domain sealing, is the hypothesis dead? Is it dead? Well, it's not dead. Well,
yes, it's dead. We're going to see that.
Well, I will explain something that you might not have known before, and it's maybe could be relevant to help you. You may want to know it. So yeah, I clipped out some stuff. I put it in the community section. All right, it's the same thing. I just clipped out these parts. Okay, I'm not gonna go through the whole thing, man. It would just take forever.
Yes, because you didn't go through the actual thing in the first place. So obviously you don't want to do it because you didn't do it in the first place.
I just think that these parts are probably more important. Okay, so It has to do with age-specific response to myonuclear hypertrophic stimulus. Okay, mock.etl performed synergistic ablation in young and mature mice and found that SC depletion prevented hypertrophy in the young mice but not in adult mice. That's very important. Listen to what they say. The discrepancy may be explained by the fact that the young mice in the maturation phase were dependent on SCs, these satellite cells, for growth and hypertrophy. So, young mice, that would be young people too. Trust me, it's young people, man. Okay? It's
not young people. We have already talked about that. But let's actually understand what they are trying to present with this data. They are saying that Murak et al. Performed synergistic ablation, which basically consists of taking one of the muscles, or well, multiple of the synergist muscles that you use for a certain motion. For example, when you are using the lat pull-down machine, you're using your lats and you're also using your biceps. Well, if we try to do some experiment with synergist ablation, and also you kind of use your rear delts, but if we tried to do synergist ablation in that case, we would extirpate or get rid of your biceps, and we would also get rid of your rear delts, just so that the muscles of your back, the lats, get overloaded more than what they should. It is explained right here. To study satellite cells dynamics in adult murine models, most studies utilize regeneration models in which the muscle is severely damaged and requires the participation from satellite cells in order to repair. Here we describe, which is not saying that satellite cells can only repair things, it's actually saying that when they can repair things, not that their only function is to do so. Here we describe a model to study satellite cell behavior in muscle hypertrophy that is independent of regeneration. Synergist ablation surgery involves the surgical removal of some muscles, resulting in functional overload of the remaining muscle, which is involved in a certain action. And you can see hypertrophy, even though regeneration has been taken out of the study, and an increase in myonuclei, specifically.
the test, forget it just because it's on mice. I don't.
Yeah, and it's basically saying that Murak et al. Performed that operation in young and mature mice and found that satellite cell depletion prevented hypertrophy in the young mice, but not in the adult mice. And then it explains basically those findings by saying the discrepancy may be explained by the fact that the young mice in the maturation phase were dependent on satellite cells for growth and hypertrophy, whereas adult mice that have attained maximal growth use the reserved transcriptional capacity of the resident myonuclei to support hypertrophy. This basically means that the young mice, which are still in the maturation phase, don't have this reserved transcriptional capacity that these adult mice have, which is basically having more myonuclei, since the act of growing by itself makes you incorporate more myonuclei inside of your muscles, because when you grow, when you're a child, and you weigh like 20 kilograms, 40 kilograms, when you grow, you're actually increasing the size of your muscles, and when the size of your muscles increase, the amount of myonuclei content inside of them, in this case, when you grow, also increases, which shows that you can basically increase your satellite cells count inside of your myofibers without actual growth, but whatever, which are without actual damage, sorry, but whatever. And basically, when you attain maximal growth, which is what occurs in human beings at the age of 24 to 23 years old, which is the point where your muscles and your body stops growing. At that exact point, you have achieved a maximal growth of your muscles, and because you have more myonuclei than child, for example, just depleting your satellite cells won't make you stop growing your muscles, okay? So what it's basically saying is that people that are near 18, 19, 20, 23, 24 years old, in the case of human beings, because rats get to adulthood in less than 1 year, that's why they are used as subjects of studies, basically. And in the case of human beings, as we were talking about, that occurs in, well, as we said, 23 to 24 years of age. So someone that is 18 or 19 years old won't have to actually be adding a lot of satellite cells to be growing, because the amount of myonuclei that they have already incorporated by their natural growth, by aging basically, can support the hypertrophy that they are going through, because of the reserve transcriptional capacity, which is the capacity to create more proteins using the myonuclei. Since you have more myonuclei because you are a grown-up, then you can basically produce a lot more protein than a child. You don't need the extra satellite cells that a child might need to actually grow your muscles. So it's not saying, it's saying that in some way it's age related. But if we extrapolate this to human beings, then the advice for the case for the most the advice for the population of lifters in general would be to if we take this data, yeah, and apply it to the population of lifters, then most of the lifters already are grown-ups and already have achieved this maximal growth. So they have this reserve transcriptional capacity and they don't actually need extra satellite cells. So for most of the lifters that are more than 18 or 17 years old, then we can perfectly say that they are growing, they are going through hypertrophy without actually increasing the satellite cells count inside of their muscles. So this debunks the myonuclear domain size ceiling for almost every person that does actual lifting. For everyone, almost everyone inside the population of lifters, of people who do resistance training. This basically goes against your entire notion of myonuclear domain size ceiling, and it's the reason why you're going to not actually understand the study that you cited, and, as you do with every study, misinterpret it.
So, young mice, that would be young people too. Trust me, it's young people, man. Okay?
Yes, young people of 5 to 6 years old. Because, let's search, when do mice reach adulthood? 3 to 6 months of age. They are already mature when they are 3 to 6 months of age. So, if we extrapolate that to human beings, we arrive at adulthood at 20 years old. So already most of the people who lived, which are older than 18 or 20 years old, wouldn't be actually growing, wouldn't actually need to use more satellite cells to grow. That's basically something that debunks your hypothesis of the domain size ceiling.
To test, forget it just because it's on mice. I know this for a fact from experience, okay?
Yes, as we have already said, he has said something completely stupid, but we are going to address it now. As we have already said, mice are not the same as human beings because some things were actually proven in human beings and not in mice. And he just said that he confirmed this thing that he has said that has nothing to do with the actual study, with his own experience. And I would actually like to ask, how the hell is he able to experience satellite cells being added to his individual myofibers? How can you experience satellite cells being added to your myofibers? That's impossible. It's like experiencing a particle of dirt entering your mouth or your nose when you're reading. That's impossible if the particle is incredibly small, as in the case of the satellite cells. So you didn't actually experience that you're lying. You're really lying in this case.
So, I wanted to talk about this a while ago. I should have brought it up a while ago, but okay. So this is one problem that young people have when they go to the gym lifting weights and they can't figure out why older people, they see these older guys walking around and they're so much bigger.
Young people in this case, if we were to extrapolate what you have found in mice, young people would be people from around 6 to 12 years old. That's young people. No one that is 6 to 12 years old, or almost no one that is 6 to 12 years old, actually engages in resistance training, so that doesn't make any sense.
And they think, holy shit, man, they must be on steroids or something, you know? But as a mature person, if you're really putting more effort into it as a mature person, you're gonna get bigger. And the reason why, because like it says here, the discrepancy may be explained by the fact that young mice, okay, so hold on a second, I'll go back to this part, performed synergistic ablation in young and mature, and found that SC depletion prevented hypertrophy in the young mice. And
he doesn't even know what synergistic ablation is, and he probably doesn't understand what depletion is. But
SC depletion, but not in adult mice. So when you don't have enough of them, and here's the thing, it has to do with maturity, SC depletion, but not in adult mice. So when you don't have enough of them,
so no, what they are saying in this study is that the satellite cell depletion that they induced in mice actually only affected young mice. So in other words, they would be basically saying that adult mice have it easier to actually gain muscle because they don't need satellite cells to do so.
And here's the thing, it has to do with maturity. So this discrepancy may be explained by the fact that the young mice in the maturation phase were dependent on satellite cells for growth and hypertrophy, whereas adult mice that have attained maximal growth.
Yes, maximal natural growth. Natural in the sense of what growth you would experience if you just put your human into a laboratory and didn't change any of the other variables of his body.
Use the reserved transcriptional capacity of their resident myonuclei to support hypertrophy.
Which is not maximal growth in the sense of achieving the maximal growth that your muscles can support.
So, because some people will say, well, you can still, there's these reports that it says that the muscle will hypertrophy regardless of the nuclei. Yes, but they still need nuclei to hypertrophy.
No, they are literally saying that they depleted satellite cells and adult mice still grew.
What they're saying here is
their muscles.
Transcriptional capacity of their
transcriptional capacity of the myonuclei that they already have. They are saying basically that the myonuclei that you already have in your muscles are enough to keep growing, to keep support the growth that your muscles are experiencing, and that you don't need satellite cells. That's what it is saying. You need the myonuclei, but you don't need the satellite cells when you are already a grown-up.
Resident nuclei, the ones that are already there, to support hypertrophy, will support hypertrophy, more hypertrophy. But to an extent, of course. You understand me?
No, to an extent, no. There's at no point in the entire article mentioned the word to an extent. They literally ablated, they depleted the entire pool of satellite cells, and adult mice still grew up.
I won't go so much further. I'll bring up a map and show it to you. So, these highlight the essential role of satellite cells in supporting hypertrophy in an age-specific manner. See that age-specific manner?
Yes, young mice, which are 6 to 12 years old in terms of human beings, need satellite cells, but not actually human beings need them. When they are adults, in the sense that they are 18 to 12 years old.
That is the difference between older people and younger people. Alright, so young rodents require SCs for muscle hypertrophy. As the resident MDS, or myonuclear domain size, hits a ceiling limit during initial hypertrophy before SC activation becomes mandatory to support further hypertrophy.
Well, what it's basically being said is that you have the young rodents, which are the ones that really need satellite cells. The resident MNDs hit a ceiling limit during initial hypertrophy before satellite cell activation becomes mandatory to support further hypertrophy. So, their MND size, their myonuclear domains, hit a ceiling, which is the limit that he's basically talking about, during the hypertrophy that was induced in them, before the satellite cells, which are outside of the myofibers, their activation is needed in order to make you grow more. So, the satellite cells, in the case of young rodents, already hit a ceiling and cannot do anything anymore to actually produce more growth inside of your myofibers. But adult mice, as he's going to read, have myonuclei with greater transcriptional reserves, which means that they are not going to hit a myonuclear domain size limit because they can produce a lot more protein than what young rodents actually can. Because they already hit myonuclear domain size ceiling, and then they start needing satellite cells to actually grow. But mature rodents don't go through that process. Well, they went through that process when they were young, but now they don't need to go through that process. They will keep producing more protein with their already present myonuclei without the need for extra satellite cells.
However, mature rodents have myonuclei with greater transcriptional reserves. So this is what they say. Mature rodents have myonuclei with greater transcriptional reserves. And
it would help that you actually explain that with your own words so that your audience can actually understand. Like I did with what was said right here, which basically says that before they hit this, before they start actually needing satellite cells, they start getting closer to hitting the myonuclear domain size of their nuclei inside of their myofibers. When they reach that ceiling, then they start needing satellite cells. That's what the first thing is saying. But mature mice do not need it.
the concept of myonuclear domain ceiling and domain size rigidity is not strictly applied to them. Yeah, but
which means that it doesn't apply to almost the totality of the lifting population in the entire Earth, because most of them are more than 17 years old and they are almost mature So they have part of these greater transcriptional reserves that actual adults, like 20 years old or greater, have. So you're basically saying that your concept does not apply to almost any human being that actually goes to the gym.
You know, as you get bigger and bigger, you have to do so much more to get more of this done.
No, they are saying literally the opposite. You don't need satellite cells to grow when you're old.
To get the progenitor to donate its nuclei. It's a complicated process, bro. And you really
No, you don't actually need the progenitor to donate its nuclei when you're a grown-up. They are saying literally that. You're misinterpreting completely what they are trying to explain there.
have to eat a lot to push that domain. And sarcoplasmic hypertrophy is very important as well. They really go hand in hand. One can exceed
But he said that that's fake. Why is he saying that you actually need it, but then he said before that it's fake? How are you going to need something that you are criticizing actively?
but definitely, yeah, it does, you need them both. Okay, but anyway. So, where was I? There is a role of fiber type as well, as myonuclei from type 2 fibers have greater transcriptional capacity than myonuclei from...
Which is the fiber types that we are trying to stimulate while we lift. So this is even worse, because the fibers that we actually use while we are lifting stuff, which are the type 2 fibers, have greater transcriptional capacity, which means that they need less satellite cells.
From type 1 fibers. Fiber type transformation during mechanical overload can further complicate the notion of the MND ceiling, as type 1 fibers made limited myonuclei transcription. Where was I? Hold on a second. Transcription reserves are...
It's incredible how the entirety, the law that I have previously mentioned, is almost completely confirmed by now. The entirety of the paragraph that he's reading completely debunked what he said.
Converted to type 2 fibers during sustained mechanical overload. Yeah. Okay, so what do they say here in the next part? They say that hypertrophism is the prime. Hypertrophism is the prime determinant of activation of otherwise SCs and the amount of hypertrophy during resistance exercise and high to moderate endurance exercises. Myotrauma and micro-injuries stimulate the release of cytokines in the immune system, which activates the satellite cell.
Yes, microtrauma and microinjuries stimulate the release of cytokines, which I don't remember if they were a type of mitogens, but let's search for it because I don't know literally everything in the entire world. Cytokines are kind of small proteins. I don't remember if they are actually mitogens. Cytokines. Well, they are saying that cytokines they do have mitogenic effects, but I don't actually remember. I'm not going to claim it since I haven't actually read the article, but I do kind of remember that cytokines that do have mitogenic effects or act like mitogens. So what is basically being said, sorry, I completely forgot what I had to do, which is actually explain what is being said right here, is that when you do endurance exercise, which can produce myotrauma and micro-injuries, which completely debunks the fact that that he previously mentioned, or the falsehood, not the fact, which is that people who go to the gym more than 2 times per week are actually just endurance trainees. They are not actually growing their muscles, they are training their cardiovascular system. He said that previously, we can see that in our previous videos. And well, he's basically debunking that fact now, because endurance exercise can produce myotrauma and basically produce hypertrophy.
Stimulate them.
And after those injuries are being produced, you release cytokines and you activate satellite cells. But you don't need myotrauma to activate satellite cells. I want to get that point completely across, because we have gone through an absurd amount of evidence that this proves the notion that you need damage to activate satellite cells and to make them fuse.
Release of cytokines in the immune system, which activates the satellite cells. Thus, it seems that satellite cell activation in resistance exercise is at least partly due to the micro-injuries and the resultant inflammatory response, which initiate the process of what? Regeneration.
It seems that satellite cell activation in resistance exercise is partly due to micro-injuries, they are basically saying that when satellite cells are being activated, it's because you have some actual damage inside of your muscles. But since they have previously explained, they saw how the myofibers of mice increased without the presence of satellite cells. So what they're basically trying to argue in this case is that satellite cells are more for regeneration rather than growth, which are 2 different processes, as we have previously seen in one of the videos. that I showed in my previous video that explained the difference between regeneration and hypertrophy in satellite cells, in myofibers. You can perfectly read the docs right here to understand why they are the two different processes, and one leaches resources from the other process, which is the actual growth. Regeneration leaches resources from growth. And basically, since they are saying that satellite cells are needed for regeneration, they have previously debunked that they are needed to grow to actually produce hypertrophy of the myofibers. Then they are basically arguing about satellite cells being needed for a secondary role, which is to regenerate your muscles. That's what they are saying. And also, a fun fact is that the inflammatory response regulates the IGF-1 factor. You can perfectly read inside of this article. If you search for IGF-1, the first mention of it is in regards to how ROS can actually upregulate it and make you grow, because IGF-1 regulates satellite cell activation and fusion. But even though what they are actually arguing about in this article is partially false, because satellite cells can be activated without the presence of damage, and they actually fuse even if you have absence of damage, which is something that we have seen in the previous videos and is in the file right here. So,
cycle of damage and repair, along with the activation of myogenic regulatory genes and increased plasma levels. When I say plasma levels, it would be plasma levels of anabolic hormones such as testosterone and IGF-1. So IGF-1, okay, that's why, you know.
The repeating cycle of damage and repair, along with the activation of myogenic regulatory genes, which basically are the genes inside of the satellite cells that, no, the myogenic regulatory genes are not the genes inside of the satellite cells. They are the genes that regulate all of the process of actual hypertrophy, and they are also in every single cell. So, and they are basically saying that all of this process of damage stimulates satellite cells to support hypertrophy, which is true. It does stimulate satellite cells to support hypertrophy, but it does so at an incredibly smaller actual range, I would say, than to an incredibly smaller degree than actual just mechanical load without absurd amount of damage. Because as we have already seen, regeneration itself leaches resources out of hypertrophy. So even though you are actually producing hypertrophy, you are producing subpar or suboptimal hypertrophy in this case, because you are damaging your muscles more than what you are actually making them grow up, right? So they can perfectly be right, and that's consistent with what I am saying, but satellite cells also support hypertrophy in absence of damage. So
a good type of starch is really good to, I would say, no carbohydrates other than the starch and protein. That's it. Your natural diet, and you can eat some potatoes to add the starch. That helps to push that domain, okay? As a young person, I wouldn't do this when I'm older, man. I'm not eating any.
That helps push that domain, but the sarcoplasm is outside the myofibers. How it will help push a domain that it's regulated by myonucleus? We don't know.
Sugar's now when I'm older. I'm not doing these things. My body, I can't handle it, man. The sugar stuff, it just, in an older body, forget it. When you're young, you can kind of handle some of the stuff, I don't know. But you wouldn't want to be a runner and be pumped. You don't want to get pumped running, trust me. That's why you want to be on a high-fat carnivore diet, high-fat animal diet.
Runners don't get pumped at all. What are you saying? They might get some burning in their calves, but that's not getting a pump. That's not the same
Diet than being on carbohydrates and running. You're going to get pumped, and that'll inhibit your running abilities. That'll fuck you up. That's for running people, man. I'm not.
How is it going to fuck you up if pumping basically means that you have more resources near your muscles to actually use?
I'm not joking. You have to get your body adapted to running on high fat, because you're so adapted to running on sugar, on drugs.
But when you cannot use fat to produce energy, you understand that, right? You have to actually turn that fat into glucose, into glycogen, to actually be able to use it to produce ATP. You cannot use just the fat to do that.
It's called sugar.
So you do have sugar by your own definition inside of your blood.
You're on drugs, bro. If you're eating anything that has carbohydrate, sugar in it, you're on drugs, man. I'm sorry, but that's just the truth.
Yeah, we aren't going to even justify what we're saying, right? Well, let's just invent things. Let's just make them pop out of thin air, right?
Okay, but whatever. So yeah, so this domain, whatever, MNT size. Yeah, so microinjuries, that's what activates it. You get the picture. According to the nuclear domain theory, the donation of additional myonuclei by satellite cells occurs when myonuclear domain reaches a maximum threshold size. See that? It has to reach, I told you that before, it has to...
No, they are paraphrasing what it says, because they are actually criticizing what it says, which is something that you should start trying to implement in your channel, because you try to respond to the things that I say without actually paraphrasing what I'm saying. Nor, because if you're not going to react to the things that I'm posting, then at least just paraphrase what I am posting, at least. It basically says, after that, among the anabolic hormones triggering hypertrophy, increased levels of IGF-1, which is stimulated by mechanical overload, which is not damage. Mechanical overload is not damage. To overload your muscles does not imply to actually damage them, as we have seen. The same amount of mechanical load can produce completely different damages in different people. So if the mechanical overload alone does stimulate hypertrophy, like they say right here, and it actually does, and it actually regulates IGF-1, which regulates satellite cell fusion and activation, then in the cases of people that are trainees who are fairly advanced and won't receive lots of damage by their training, they will be actually having lots of mechanical overload and almost none of damage. And based upon what they are saying, they will still grow, because they are just measuring mechanical overload, not damage. So they are basically saying that someone without damage will grow, and with sufficient mechanical loading will grow. So that goes against what you're saying. Again, no article actually agrees with what you are putting forward as advice in your videos. Then it says that these increased levels contribute to hypertrophy by inducing satellite cell proliferation and differentiation, which is what IGF-1 actually does. And, well, yes, it triggers the proliferation of myelinasts, but that's only in cases of regeneration, because you only use myoblasts for regeneration. Well, no, sorry, you actually use myotubes for regeneration. Repression of, well, that's, and then it's completely cut off. So that's basically what it's saying, and it doesn't agree with what you are trying to take out of it, nor it's actually what you are taking out of it. So
reach an MND size limit, a threshold limit. Once it reaches that limit and there's a micro injury, only then will it donate its nuclei to that.
No, you don't need the micro injury to actually make satellite cells being activated and for them to fuse, because IGF-1 is even upregulated in cases of absence of damage. The first eye inside of my dogs shows that. And IGF-1 regulates, therefore, the activation and fusion of satellite cells. So in those cases, IGF-1 provoked the fusion of satellite cells even without damage. So
that domain to support further muscle growth. What does that mean? Somebody asked me, hey man, does HMB, if I take HMB, a supplement, that's gonna somehow, it's gonna suppress something and cause muscles to grow magically, a magic pill? I'm telling you, there's no Jack in the Beanstalk and magic beans, bro. Ain't no magic beans gonna grow any muscles, you get it? They're supplements. They may help and aid in something, but those supplements, those amino acids, they're found in food, they're incorporated in food and meat and fish and whatever. So does it really matter? Okay, they have concentrated in high dosages, right? These amino acids. They do something in high dosages. They do stimulate something. You know what I mean? But the problem is this: when you stop taking it, it was induced artificially. It wasn't induced naturally, and so
the process by which you create a compound does not dictate its functionality, because the same exact chemical compound can be found in meat, and if they are the exact same, then they both have the same function. So you cannot say that one of those actually causes something and the other doesn't, because they are the same thing.
Bye-bye, all that, whatever. But anyways, yeah, you get the picture. So among the anabolic hormones triggering hypertrophy, increased levels of IGF-1, which is stimulated by mechanical overload, which is muscle damage, contribute to hypertrophy by inducing...
As we have already mentioned, that's not actually damage. And we have proven that not only in this video, but basically in every single one of my videos.
Proliferation and differentiation. You're talking about muscle damage.
No, that's not muscle damage, because they're talking about IGF-1 and it is upregulated in absence of damage. And no, this false.
Increasing the expression of cell cycle progression. So look, when you max out that domain, this is how you max it out. You need to be in an anabolic growth state. That's how you max out the muscle cells. You max them out. When it reaches maximum threshold, the muscle cell, the MND size limit.
You don't actually need to be in an anabolic growth state. You can still make more proteins inside of your myofibers, even if you are cutting. So that's wrong. Why would you actually go through that consequences, right? If the amount of protein that you're ingesting is the same, when you're cutting, you don't decrease the amount of proteins that you're ingesting, so it doesn't make sense what you're saying.
In a cell reaches a maximum threshold when you're in an anabolic growth state. Okay, in an anabolic growth state, it'll reach that MND size limit, and then it'll donate its nuclei if it was injured in that period of time. That's why I say
you don't need injuries to actually cause growth, and they don't even mention injuries in this case. You are actually taking it up from your own interpretations, which are not the actual thing you are reviewing.
I do a very sophisticated workout regime to get that. I tried to explain this before. 5 times 10 or 5 times 12, all muscle groups, and I mean all muscle groups for total upper body work.
But he previously said that he loved doing like 30 to 50 reps of exercise. Now he has moved towards less reps. Why the sign change? Are you actually noticing that training like normal people will get you somewhere?
Workout, and then the next day legs. But after your workout that day, let's say it was a Saturday, you did your whole upper body. You head down to a buffet. I don't know, you got a local buffet or something, because I don't think you're gonna eat like that at home, dude. And so you need to eat a lot in the morning, and then you head down to a local buffet after your workout. Time it. I don't know if you have time for that. I don't know if it's dinner or lunch, whatever. And go eat for whatever hours they're open. If it's 4 hours, eat for the entire 4 hours. Sit.
What? He's joking, right? Who is going to go to a buffet and eat for the entirety of the duration of time in which they are open? Who is going to go there and eat like for 7 hours, 8 hours? Are you dumb? You actually think that you need like tons of food, even though muscle building actually occurs at minimal intervals week to week? How is all of that food, which are several kilograms, for what you're mentioning here, going to cause a significant increase in your muscle size if it can increase at most in a single week 0.4 kilos? In your mass can only increase that much in a single week. You can perfectly watch Jeff Nippert to confirm what I am saying, because he has made some videos about the comparison between the amount of muscle that people who have steroids can produce in a single week in comparison to the amount of muscle that normal people can produce in a single week. So those lots and lots of foods won't go through actually make you grow muscle. They will just make you fat.
Sit down and try to eat as much as you can for that 4 hours. But try not to eat too much of these. Try not to eat too much of these fillers or weird stuff, plant foods and stuff, and sugary stuff and all that. You can eat some carbohydrate, potato, and I would stick to all kinds of different proteins, shrimps, mussels.
Why potatoes? If they are just chains of carbohydrates, they are chains of sugars. The complex carbohydrates are literally the same as normal carbohydrates. As a matter of fact, complex carbohydrates are chained carbohydrates, so they are composed by normal carbohydrates. So when your body actually breaks them down to use them, they are the same. They are literally functionally the same.
Whatever's there, seafood stuff, whatever, and beef and whatever else is there. I don't know, chicken, something. You figure it out, man. Roast beef, whatever. You eat the good stuff, okay? And you sit there and you take your time. You eat and then you drink water and you keep packing it down, and then you leave. You get it?
You're going to live like a pregnant woman if you do what he's saying, and it doesn't make any sense. Also, it's funny that he preaches what Goatis says, even though he says that eating in an anabolic growth state ages you and makes you older. So that's very funny, which is actually wrong, as we are going to see in the next video, because anabolism is present all throughout a person's life, and it's actually needed to grow, because anabolism is the process by which you create new substances out of less complex substances. So to actually live, you have to do that. That's the problem.
Yeah, and so that will suppress the catabolic hormone. It'll convert the catabolic hormone to an androgen, so it doesn't have to compete with the myocytic androgen receptor, making you anabolic, and now you've suppressed it.
Sorry, but you cannot convert cortisol into testosterone. You know that, right? They are two different hormones. Upregulating one and downregulating one does not mean converting one into the other. That's wrong. And also, cortisol, it's just upregulated temporarily. It's what you would call it in epistemology, in epidemiology, those areas of research, acute levels, no permanent levels. So you don't actually need to care about that.
The breakdown, in other words, you exceeded breakdown in protein synthesis. Protein synthesis needs to exceed.
That's why you cannot say that exercise is something that ages you, because it releases cortisol. Because if you actually take a look at the amount of cortisol during the entire day, the net amount of cortisol that was circulating your blood, then you will see that you have even less cortisol than someone who stays at home sedentary doing nothing. Because the acute levels of cortisol are then compensated by reduced stress levels during the rest of the day, and therefore the amount of cortisol that you end up happening if we rarely tap this down regulation and this sudden up regulation would be less than the amount of cortisol that someone sedentary would have, which is something that already debunks what Goatis is saying, but doesn't matter.
Breakdown. It exceeds that breakdown when you're in anabolic growth state, like it says in science. It says, in order for muscles to grow...
No, you don't need to be in an anabolic growth state to actually grow your muscles. First of all, that's what he's referring to. Anabolic growth state is not actually anabolic growth state, because anabolism is constantly occurring in every single site at your body, inside your body, because several structures are wearing out and being replaced by cells or by other new structures. So you're constantly under anabolism. But what he's actually referring to, which is a caloric surplus, you don't actually need a caloric surplus to grow. When you're doing body recomposition, you will still grow. Obviously, it's not an efficient way to actually grow, because it would be better if you just do bulk and cutting. It's 10 times better, but it already proves your claim by counterexample.
Protein synthesis needs to exceed that breakdown. If it doesn't fucking exceed that fucking breakdown, then you're not gonna, like it says here, you're not...
Repeating the word fucking multiple times won't make your point true, right? You know that. And also, that's not enough to grow, as we have mentioned like 30 times in the previous videos. You still need some stimuli to actually grow.
MND is not going to reach maximal threshold, and if it doesn't reach that maximal threshold, you can go and try to injure these muscles as much as you want. It won't work anymore. And the only way...
MND does not need to reach that maximal threshold. Is he saying that the minuclear domain size does not need to reach its maximum? I don't know why he even mentioned the minuclear domain size reaching its maximum and that being not needed, because he's actually saying that the minuclear domain size ceiling is not applying in this case, because you don't need to actually make your minuclei reach ceiling domain to actually cause growth. So that's really funny that he's saying something that goes against what he's preaching.
You can get any other growth, eke out any other growth, is through an adaptation process. In other words, you must do things that you're unaccustomed, unfamiliar with.
No, adaptations do not occur by necessity of changing exercises. Adaptations occur when it comes to stimuli. If you change the stimuli that you're experiencing, then you are going to not be adapted to the new thing that you are doing. So you don't need to change the exercise. To change the volume of the exercises, to change the weight, to change the reps, to change the order, already causes you to get a different stimuli, to receive a different stimuli, which you are not adapted to. So you don't need to change the movements that you're doing to actually grow. That's wrong.
That you've never done before or unaccustomed to doing. In other words, if you've never done these other type of exercises before, you will get...
No, you don't need to change the type of exercise. You need to change the stimuli. Your body does not care about what exercise you're doing. It cares about the stimuli that it's receiving.
Adaptation there, but then it'll end. There will be no more growth. You understand me? But if you want a further growth, even in the exercises you're doing...
It will end if you don't change the exercise, even though you have changed literally every other variable related to it.
In the gym, you got to resensitize. You have to give your body a week to repair and remodel. So you need to do the...
No, you don't need to resensitize. Resensitization is something that only people who train very hard should actually do. Like power builders or power lifters, those persons should absolutely do that. Because you actually need to do a resensitization after training for long times, because the volume that you need to actually cause growth is incredibly high. That's what happens. To actually, the volume to which you are not adapted is incredibly high. So in order to not having to do like 36 sets in a single week, you just resensitize, and when you come back 2 weeks, 3 weeks after, you now have to do like 2 sets to just grow. And that only makes sense after you have finished a mesocycle. To do that constantly will only make you get some growth, increase your strength, then completely lose that small increase in growth and strength that you received during that single week, and then get it back the next week, and then lose it, and get it back the next week, and then lose it. You have to actively train to maintain or to even generate enough of a stimuli to actually cause growth. You cannot just do periodic lifting. It doesn't make sense. We have already been through it, like I explained it in another video using a graph that I made in Paint. So
the whole upper body in one shot. It's got to be 5 times 12, between a 65 75
the whole upper body in one shot. What is he doing? A 4-hour workout? That doesn't make any sense.
a pound lift, whatever, you figure it out. Lift something heavy, but not heavy enough to kill yourself. That you can make it for 12 reps, okay? And so you cause enough damage in the upper body, you go eat for 4 hours.
Why 12 reps and not 13, 14, 15, 8, 9, 10, 11?
You eat in the morning, and you keep eating all day, all night when you get home. Just keep eating, bro. Wake up the next day, do your legs, and repeat the whole cycle. Buffet.
But you don't actually need to grow the same way, the same day in which you have gone to the gym. You don't actually need to eat a lot. As a matter of fact, you should eat more the next day than in the first day where you went to the gym, because the process of regeneration only starts after 24 hours. Or 24 to 18 hours, and if you do have the effects of the repeated bout effect under you, then you can get ready for the next training session in even less time, which is incredibly good, because it doesn't matter that you won't damage your muscles, because that's something counterproductive and that you don't actually need to grow.
Eat this, that. Eat so you're in anabolic growth state, so you're not hungry. If your belly is empty, if you're even hungry, you have hunger pains, your nitrogen balance is dipped, and you're not in anabolic growth state anymore, and you can't.
Yes, you should eat. You shouldn't eat to the point that you actually have your belly asking you for food, like you're going to die. But
push that donate. That MND size will not reach its maximal threshold where it's going to actually donate any extra nuclei to support further muscle growth. You understand me?
If you don't eat like a crazy person during an entire day, why? Why? You don't give any reasoning as to why.
Why would it support further muscle growth if it's highly regulated by myostatin, follistatin, and the like so?
But what does myostatin and all of those regulatory hormones have to do with eating lots of food? Myostatin, the only thing that myostatin does is negatively regulate the amount of muscle size that you can gain from training or from your regular activities. It doesn't regulate how much, the food that you eat won't regulate how much effect the myostatin gene has over your body, because food cannot actively change the ADN of your cells. That cannot occur unless that's radioactive food, but I don't believe that anyone here eats plutonium or uranium. So
well, if the gasoline is not filled in that tank, why would it want to donate any extra more gas?
Yes, but you are not filling the the tank with gasoline. You are getting a motorcycle and then putting inside of it 10 cubic meters of gasoline, which would be like an entire room full of fuel. So it doesn't make sense what you're saying. You're talking about going 4 hours to Abu Fed to eat
gasoline to support.
You can perfectly do that. I am not criticizing the fact that you go to Abu Fed and eat for 4 hours, but don't say to other people that you need that, because that's false.
Further growth. Why would it want to do that? It won't. Get it? So stop wasting your time.
No, because it doesn't need 10 fucking cubic meters of gasoline to actually work. It's just a motorcycle.
Like blah, lifting a heavy weight. Okay, so you get the picture now, right? So yeah, contribute to hypertrophy, inducing SC whatever. By increasing the expression of cell cycle progression IGF-1 triggers proliferation of myoblasts, which then followed by triggering an expansion of myogenic regulator factors, resulting in differentiated myoblasts through the role of SC activation. Muscles and age-related muscle loss, thus, so it tells you, rescues atrophied muscles and age-related muscle loss, thus further accentuating its role in muscle growth and hypertrophy. There you go. So you get the picture. It tells you right here everything you need to know.
Yes, you didn't understand a single word of what was said right there, but yeah, we get it. Yeah.
All right, this is the conclusion. In conclusion, it seems that the concept of the MND size limit during hypertrophy is conditional and not universal. It's conditional but not universal. I already know that. Has various factors, including.
So you cannot say that you need more satellite cells to go through the domain size ceiling, because now it's not a universal thing, which means that the word need should be taken out of the sentence. You should now say that that only young people, and we're talking about people of 6 to 12-year-olds, need to get more satellite cells to actually go through the domain size ceiling limit of their myofibers. If you were to actually talk about grown-up adults, 20 years old and greater than that, then you should be saying that you don't need to get more satellite cells to go through the domain size ceiling, because there is no such thing in the first place. So
satellite cell activation, see, it's smart. It's dependent on satellite cell activation. It's also dependent on age. It's dependent on fiber type. And I'll bring this up in a second. I told you there's many different fiber types. People don't realize that. The duration and type of hypertrophic stimulus can determine the presence and or extent of the MND ceiling.
So the presence or extent of the mononuclear domain size ceiling is now relative, and also it's conditionated by a lot of things. So you cannot actually say that you need to, you will reach the domain size ceiling and you need more satellite cells to go through it, because this the existence itself of the MNT is related by a lot of things. So you have to first prove that the person in particular that you're giving this advice to actually has the concept itself of the MND size ceiling affecting his case. Because if you're talking to grown-up adults, which is your main public in this case, the main people that watch you, then you're lying. You're lying to them. That's false. This article itself proved that.
During hypertrophy. So these things are all important. If you don't think they are, then good luck. That's why young people they don't understand that. They're not like older people. Mature, that's why people always say, oh, he's got mature muscles. He's got maturity in there. Mature muscles, mature this, that. Well,
yes, but then you don't need satellite cells if you do have mature muscles.
Yeah, I guess you could say that. I don't know about drug addicts on steroids, but natural people and older people, we mature. You look better and more mature when you're 30, as opposed to somebody who's 19, 20, 18 years old. See what I mean? They may be young.
You look more mature? Not really, for a person who criticizes literally everyone in the internet, insults them, and also shouts at them. You don't actually look like a very mature person.
They may have high hormones. They may have high more hormones. They can get an adaptation in lifting a heavy weight.
They may have more hormones. What? The levels of testosterone that someone old has are in most cases lower than young people, so that doesn't make any sense in the first place. But why? Why would be that true in the first place?
If they keep calibrating their nervous system to do that and proliferating these more units and these androgen receptors, whatever,
Yes, but if you don't actually make more motor units, then you will have useless myofibers, which is related to the concept of fate strength that you uphold constantly. So,
the heavy weight. But they're not getting bigger in muscular size. They're not getting bigger. See what I mean? They're not getting bigger unless they do specific things, like I said there, like I read to you. Okay, so yeah, that's why older people can get much bigger. But anyway, you get the picture. So let me bring up one more time. What they talk about here is fiber type. So
older people can get much bigger. Didn't you say that they have to make more efforts to actually get bigger?
They talk about fiber type in here, right? I don't know if I can find it now, but so here's a map. This map right here. It says activation of satellite cells, see? And incorporation of new myonuclei. See that cell way there at the top, the satellite cells? No further expansion of MNDs. There's no further expansion of MNDs. It stops right there after this overload. Okay, hypertrophy with MND ceiling limit. There you go. Okay, but here on the left side, it says hypertrophy without MND size limit. Further expansion of MNDs without activation of satellite cells. And that's when they're talking about maturity, mature people. You got young people, mature people. See that?
Which are almost anybody that goes to the gym. I've never seen a 6 or 12-year-old go to a gym, so it would at least personally apply to my case.
Anyway, yeah. These are scenarios. They say diagram shows scenarios.
Yeah, but they are basically saying that hypertrophy can occur without the MD size ceiling, so that's disproving what you say.
So hypertrophy with or without myonuclear domain. And you already know, I already explained it to you, it has to do with, it's age-related, yeah? It's age-related and maturity.
Yes, it's age-related, but it doesn't matter in the case of human beings, because almost all of the people that go to the gym are actually 18 years old or even older. You have some 16-year-olds, 17-year-olds going to the gym, but that's not the majority of the population of lifters.
So, well, here they talk about the type 1s and type 2 fiber types. There are fiber type A and type B as well, and type 2 muscle fibers.
No, we mentioned something before about type 2 fibers, and we said that they don't really care about the domain size ceiling, as they mentioned in the actual article. And these are the fibers that we try to train when we do resistance training.
Come up here. Maybe it's here, maybe it's not. I don't remember. It could be in another report. But there are different types of fiber types, man. How they act and what they do are totally different. Initial hypertrophy in 3 to 5 days following synergistic ablation occurs without myonuclear excretion, followed by the addition of new myonuclei to support hypertrophy. After 2 weeks.
So you have hypertrophy without getting more myonuclei? Yeah, they also ablated the synergistic muscles of the mice, in this case, to make them be overloaded and to actually make them grow. And that's the study that I cited, because they are talking about the respective 60 and 275%.
Weeks of functional overload, the myonuclei content increases by 60%, and satellite cell content increases by 275% compared to sham control muscle. Since 12 to 15 days of synergistic ablation results in even greater hypertrophy, this indicates that prolonged post-operative durations of synergistic ablation lead to an increase in the amount of hypertrophy. More hypertrophy, yay, okay. So
He didn't even understand what they were talking about. He just got happy because the word hypertrophy was mentioned.
here's some of the types they say they right here. Both types 1 and type A fibers, but decreases in type 2 XB fibers. This is explained by the parallel increase in myonuclei count, fiber size in type 1 and type 2A, but not in type 2 XB fibers. These findings differ in different muscles based on the duration of the overload. For example, during the early stages of compensatory hypertrophy, muscle fiber structure abnormalities play a significant role in SC activation. However, in later stages, increased levels of muscle activity lead to satellite cell activation. It will lead to it. It will lead to it. Depends what you're doing. I don't know. So
He isn't even paying attention to the things that he's reading.
yeah, I'm gonna leave it there. I'm gonna leave it at that, dude. So I'll go back here again. This is another one I just posted because somebody was asking me about, remember hydroxybutyrate, HMB, so hydroxymethylbutyrate, whatever, HMB. They say too, it enhances the proliferation of satellite cells in fast muscles of age rats during recovery from disuse and atrophy. So this may be good for old people, I guess too. It's also good for young people. It could help you. I can't say it's a bad thing. Loss of myonuclei can be bad. A loss of myonuclei by apoptosis is thought to contribute to sarcopenia. It does.
Yeah, losing myonuclei is something very bad, which is why not training is not a good thing, and that's what Goatees promotes.
It's the overuse of it or the loss of it.
And it's not actually natural to lose that muscle, because that's your body overcompensating in such a way because of being literally unaccustomed to being in such sedentary conditions, because human beings were never sedentary in the first place. So
Later, the non-activation of it, you can lose them.
in the first place, as a matter of fact, human beings traveled lots of kilometers and had to track their prey down and to actually run a lot to do so, because they would actually run as much as they needed to make their prey, hunter-gatherers, we're talking about them, to make their prey get tired, and then they would kill it. But they would have to be running for hours before actually achieving that goal. So we were really highly active when we were in the starts of humanity.
Shown that the leucine metabolite, whatever HMB, suppresses apoptotic signaling and the apoptotic index, the ratio of apoptotic positive to apoptotic negative myonuclei during muscle disuse and during reloading periods after disuse in age rats. However, it is not clear if the apoptotic signaling indexes were due to only preservation of nuclei or perhaps.
Is he going to say anything relevant in regards to his previous arguments or not?
I've also reduced the apoptotic. This is way too long, bro. So yeah, let's do their stem cells. So treated muscles compared to vehicle transcription. I don't know, but acids are great. I think they're wonderful. So yeah, man, I don't know what else to say to that video. Tell me what you think about that. Like, subscribe, support the channel. So there are many factors that go into why natural people have so many problems when it comes to building muscle and a whole bunch of stuff, man. And I'm just telling you right now, if you don't accumulate more myonuclei now when you're young, if you don't force that domain, when you get older, you're just gonna deteriorate.
You don't actually need to do that, because the rats that they are talking about, the old rats, they got those myonuclei, that extra transcriptional capacity by just growing up, and the natural process of growing up increased the amount of satellite cells that they had inside of their muscles, because your muscles actually grow up with you as you actually grow up. The same happens with your bones, with your extremities, and all of that.
Disappear and become sarcopenic. You can become osteosarcopenic like Jason Blaha. Even though he's lifting a heavy weight, he thinks that lifting weights, just doing his little shitty lifts 1 hour every day, is contributing to bone mineral density. Not necessarily. Not necessarily. And he could be using up the stem cells by being in an adapted state.
Yeah, but when you are actually doing 1 RMs and very high weights, you actually get bigger bone density. A proof of that, you have some strongmen who had their bones actually tested in labs, and they figured out that they have greater bone density. So,
like the satellite cell, you understand me? It's being used up. He's not regenerating more of them. So yeah, you may be proliferating them, but they're not differentiating, splitting, dividing, increasing numbers. Lifting weights, just doing his little shitty lifts 1 hour every day, is contributing to bone mineral density. Not necessarily. Not necessarily. And he could be using up the stem cells by being in an adapted state, like the satellite cell. You understand me? It's being used up.
He could use the stem cells by being in an adapted state. What does that even mean? That's pure word salad.
He's not regenerating more of them. So yeah, you may be proliferating them, but
he's not regenerating. If you actually use satellite cells, then you actually cause them to regenerate. It cannot be the opposite case, because asymmetrical division takes place, and each time your satellite cells are activated, a backup of those satellite cells, which is bigger than the initial colony, is created. So that's false. When you activate your satellite cells, they will regenerate by necessity.
But they're not differentiating, splitting, dividing, increasing numbers.
They are not proliferating, but they are, because proliferation immediately follows activation and is internally regulated by the satellite cell. And what did he also say? they are not splitting, meaning yes, they are, because activation implies that they are going to then proliferate and divide. So,
I believe in hyperplasia. He's gonna say he got some DOMs or something, but I don't believe it.
but hyperplasia has nothing to do with the splitting of satellite cells. That's satellite cells differentiation, which is not hyperplasia. Hyperplasia is the differentiation of the myonuclei that are already inside of your muscle cells.
I don't believe what he says. He's just making up shit, man. He's a lazy guy. He's full of shit. He's the
But you are the one who's making up shit. You don't even read the things that you bring up.
laziest lifter I've ever seen on the entire planet, bro. He'd die if I put him through a weightlifting session like what I do. He would die. He wouldn't make it. He'd be dead. He wouldn't make it. He'd huff and puff and
Which means that you shouldn't be doing that because you actually want to grow, not to kill yourself.
screw off. He has no athletic abilities. That's the problem. I have athletic abilities because I've done a lot of athletic things and I still do that. I run, I swim, I do everything. I play every kind of sport, I do everything. Rock climb, you name it. So yeah, I think personally you should focus on being, athletic.
How is he rock climbing with his weight? He weighs like 260 pounds.
It's very important, not just the gym. Gyms are great if you go there to build muscle, but I don't go there for anything else other than building muscle. That's it. I just go to gyms. I want to build some muscle to get physically stronger and better, so I don't wither away as I'm getting older. I'm not interested in lifting the heaviest weight in the gym. You can lift heavy weights if you push that domain and get bigger and stronger. See what I mean? But that's really
You don't need to push that domain, as we have already proven during the entirety of this video. But okay, he's giving actually good advice, which is to go to the gym and build muscle at least, and he can have his own preferences. That's not wrong, but it gets wrong when you actually try to force those preferences to other people. So
up to you how big and how strong you want to get. But it doesn't affect you as another person to regenerate. But yeah. Anyways, I'll see you in the next one, friends. I gotta go, man. Like, subscribe, support the channel, support the algorithm. I'll see you in the next one. Ciao, guys. And like I said.
oh, the same. We have reviewed 2 videos. I don't know if we were going to do something else. Let's go to his community section. He talks about the cytoplasm. Yes, both of 2 exist, but one of those cannot justify any increase in growth, and this is wrong, as I have already mentioned, because it's not an increase in muscle glycogen storage as is 6 weeks of training. This exact article shows. And the cytoplasm is not the sarcoplasm. Yes, androgen receptors also upregulate myofiliar growth, as we have seen. And also this article right here has a lot of discrepancies with other studies, as we have shown with the mice. And that's it, I believe. Well, see you in the next video, guys. Bye.